discriminations in the design, so that when there is small downstream, only downstream breaker will trip, not the upstream. Talking about the three different curves, the B curve, the C curve, and the D curve, as long as your IN, your nominal current is the same, then your overload curve will maintain the same. Look at this curve. Right, so this is B32, C32, and D32. They are all the same. Oh, sorry, they are all of the same overload, but different magnetic curve. So as I said, as long as the nominal current is maintained, your thermal curve is the same, only your magnetic curve will change. So this is to illustrate on the application example. If you have a 2.5 square mm cable, in which the maximum is 24 amps. If you have a load, okay, that is running at maybe 15 amps. So the load of 15 amps is within the 2.5 square mm cable capacity. Okay, but the starting current may be very high. Okay, it could be, let's say, 5 times or even 7 times. And this may cause nuisance tripping to the outgoing breaker. And a lot of contractors, sorry, not you all here, mainly the aircon contractors, when they install aircon, let's say the big aircons, 3 horsepower or 5 horsepower aircons, the running current actually is lower than the cable carrying capacity. Okay, where cable current capacity can go up to 24, running current may be below 20 amps. They should be able to still use the 20 amps breaker, but because of the starting current causing the nuisance tripping, they change to 25 amps or 32 amps. Okay, these are the practices that we need to stop because it exposes the occupants of the house to danger, where when there's overload, the cable is not protected and it may cause fire. Actually, the solution is to change from, if they are using type C, to use type D instead. So, okay, by shifting the magnetic curve one step away, okay, to ensure it will avoid the starting current. That is the practice actually, not by changing the IN, the nominal current. Okay, I have a very simple example here to illustrate what I have said just now. Here you have a 9 amps rated load. Okay, the load is rated as 9 amps. And your cable, because it's just 9 amps, and you can use a 2.5 square mm cable with a maximum current carrying capacity of 24. Then you choose a 10 amps breaker. Okay, you can use 10 amps or 20 amps or 15 amps, no problem, because your cable is 2.5. But you say you want to have the overload protection as close to the running current of the load. So that is why it is good to use 10 amps. Right, but now the issue is which one to use, type B, type C, or type D. Okay. Okay, which one to use? Okay. It all depends on your load type. How is the starting current of your load? If your load is a resistive load, okay, before we go into details of this particular example, I would like to bring you to know one more issue or one more parameter, what we call CUC, current utilization categories. If you could on your smart device, go to Google search, okay, and then you type in current utilization category, CUC. Then you press enter, okay. Then you can see some options and explanations of current utilization categories. You may open the one from Wikipedia. Okay, once you open the menu from Wikipedia, you go to the Wikipedia link, and there are options in Wikipedia for you to click on table. There's a table under the Wikipedia for the CUC, current utilization category. So in this table, it is shown there. Let me check again, because last check was I think a few months ago. One moment. Okay, when you click on table, it will show you AC1 until AC140. So there are different types of AC current, depend on the type of load. If you look at the resistive load, it falls under AC1. If it's what you call motor, induction motor or squirrel cage motor, it falls under AC2, AC3. Depends on the on how you use. If it involves inching, then it's AC. Inching is AC4. Yeah, inching is AC4. This is very important for designers to know your load. Okay, because wrong selections of current utilization categories means your design is wrong. For example, if you are designing or selecting circuit breakers and contactors for capacitor banks, okay, be alert that for capacitor banks you need to use AC6B. Okay, it's a special contactors for AC6B. And how are you derating your breaker normal type C, for example, to be used under the AC6B category? So it is very important for you to know all these type of AC, and if you are involved in the DC design, also you have to know all the type of DC current utilization category, so that you will be able to select your contactors, your circuit breakers, your switches correctly, to ensure that your contactors, breakers can withstand
ada
the
setengah
static
tiga aku tak
current
faham
during
tapi
operation.
fahamlah cara baca tu.
Apa yang
Okay, so now for in this
apa breaker
example, if
current
your load
kan
is
bila dia nak trip
purely
tu.
resistive, there is
Karakter dia macam ni lah,
no
MCB.
or very small
Lepas tu
amount
kena tengok
of
kita punya housing
inductive
selalu pakai macam mana,
component, capacitive
untuk transformer pakai macam mana,
component. So your load will have
nak
a
kena pakai
very
tag mana tu,
smooth
tag D
running
untuk
current,
transformer selalu pakai,
similar to
tag
something
D
like
ni
this.
untuk housing. Itu
Okay,
lah
very smooth
ni IN dia ni.
starting current and running current.
Lepas tu je pastikan running starting dengan running ni tak langgak dengan ni lah
what you call
kan, kalau langgak tu trip lah
starting current. It's a very smooth starting current. So in this case, if your load is purely resistive like this, you may use type B. Okay, look at this type B, B10. Type B 10 amps, no issue. Okay, but if your load is a little bit inductive, and it may need to have 4 times of the rated current to start. Okay, it looks like this, the green colored one. Okay, so 4 times 9, okay, 4 times 9 is how much? 36. Okay. So here is 20, here is 30. So 36 already into the type B magnetic curve. So in this case, you are no longer able to use B10. You should now use C10. Okay. If your load is very highly inductive, starting current 8 times, so 8 times 9 is about 72, so more or less about here. And now in this particular case,
Tapi
you are
sekarang
not
ni,
able to use
tak cakap dengan
I
engineer
think
atau bombos, dia cakap dengan
N
cloud
times
juga. Dia
you
kata
have
kalau
no
bos dia tak puas
choice
hati
but
tadi,
to
dia
use
kata
time T.
kau punya
So in
engineer
this
ke
case,
punya
you
bos
use
kena datang
time
sini
T10.
dia
Time
explain kat mereka
T10
dengan
amps.
yang lama punya apa semua.
Alright.
Oh,
Now,
aku tak boleh nak
people
explain
say,
pun.
can we use
Tak tahu sekarang dengan ayam
16
kau.
amps
Najak dia
type
T.
C? Yes, you may.
Kita
16 amp type
Tak
C,
apa.
because when you use
sebab
16
dia
amp
penduduk
type
Malaysia,
C,
benda-benda dia pun pecah.
the lower limit is 16 times
Lepas tu
5,
sebab kau
which is
cakap kata
80. It
suruh dia
will
pecah
be
balik,
more
bos
than
aku
the
dah
starting
rasa
current
macam
of this blue curve.
mungkin ada pengalaman
But
orang yang
once
apa
you
ni yang
change the
lepas tu
IM,
ada
your
melibatkan
overload
bilah bas
protection
ni yang
also
dia mesti
shifts
jadi macam
to
ni.
the right,
Anu,
away from the load. Okay, that is
aku cakap tadi tak
the
ada
concern. If you don't mind for your overload protection to shift away from your load, it's okay to use C16, because C16 is still within the current carrying capacity of the cable, and at the same time it is the magnetic curve is away from the
Tak
starting
boleh guna
current.
abang ayah pun.
Okay, so you may use also C16, provided that you are okay with the
Dia pun
overload
duk macam
protection.
salah yang kita aku cakap lah.
Okay, I hope that you all clear with this
barang
concept
dia kemungkinan
in selecting B, C, and
kemungkinan
D
dia pun
curves.
kena check dia
And the
punya
same
meter
concept
pupur
will be applied
berapa tahan
when
lama. Kita kena
to
standby tu
do the LSI
dengan
setting
bah apa semua tu
in
tahan berapa
MCCB
banyak
and
pressure pun.
ACB.
Tapi dekat dia kalau kita boleh tahan
Besides,
10 pun tak ada
for
masalah.
achieving
Sebab kita tak
certain
pecah pun.
percentage of discriminations, you would be able also to avoid nuisance
Ayah
tripping
aku nak pergi juga ni.
during
Kau
starting.
tidak nak jawab macam mana?
Okay, question number 4.
Tak apa nanti.
Okay,
Ayah
just now
aku
you
call
have
dia.
seen the curves during an
Sebab ayah aku tak cakap
overload
apa dia.
fault.
Tu yang salah.
At how many
Dia
percent
sekarang
of
ni dia dah
IM
macam
shall the
tak dengar
breaker
lah dekat
trip?
bos dia dah.
Okay, so
Dia
30 seconds from now.
Bukan direct dengan aku. Kira dia bagi aku dia tak pergi sampai kat korang pun. Tapi kalau kata bos dia tak boleh endur, dia kata kalau kata nak panggil meeting, sebab bos dia kata kalau kata itu dia nak panggil juga. Kan? Korang tahu orang ni kata dah. Tu.
Ayah aku kena pergi ni macam mana.
Tapi nanti dulu lah kalau kata dia panggil.
Okay,
Takut
time's
dia
up.
tak larat nak
That
pergi.
is the answer.
Kita nak pergi saja macam
Anyone
itu.
got the
Tak
answer?
boleh.
Maybe you can share on the
Nak
chat
tanya
box.
benda-benda
Anyone got the
teknikal ni
answer?
banyak sangat. Aku takut tu. Aku silap
Before
cakap.
we release the answer, can maybe share what,
Tapi tak apa, aku tak tanya juga.
you have answered just
Tanya
now.
ayah aku dia. Kalau ikut hang lebih tahu kalau ikut.
Mana aku lebih tahu ya, aku kena buat
Anyone
laptop,
would like
minta
to
barang
share
ke
your
laptop,
answer?
Memang lah
pesan.
tapi macam mana hang lebih tahu.
Aku kan tak tahu apa pun.
Teori aku pun tak mengena tengok dengan apa yang jadi kat slide. Tu yang takut tu.
Aku harap dengan apa
And how many percent of IM shall the breaker trip during overload?
kita
The
pada
answer
engineer.
is anything above
Ini Cik Salim lah,
30%
Cik Salim
of the
tu.
nominal value.
Ha?
Let's say if your breaker
Engineer.
is 10
Engineer tu.
amps breaker,
Suruh Cik Salim biar.
at
Pasal
11
Telekom
amps
ke
load,
luar.
it will not trip. At 11.3,
10 M
your breaker may trip,
berapa persen?
but
Kalau kita
you
ambil.
do not know when. It could be after 1 day, it could be after 1 week, nobody knows. Okay?
13%.
At 13% more than the nominal current,
Daripada
your breaker may trip, but
dalam
the
13 M lah.
time of tripping, nobody knows when. Okay, so that is the answer. Okay, look at this chart. At 13% of the nominal current, it will never trip. Slightly above 13%, it will trip, but we do not know when. Okay, it could be after 1 day, nobody knows. But if your load exceeds by 45% of the nominal current of the breaker, then your breaker must trip. Okay, I use the word must. The breaker must trip within 1 hour. That is the rule. Okay, look at here, 45% overloading. Draw a straight line and you can see it touches the upper limit of your thermal curve at 3,600 seconds or 1 hour.
1 hour.
Right, so that is for you to understand, because sometimes you receive inquiry
MCB tu.
questions.
MCB.
Your breaker already now 20% overloading but has not tripped. Okay, you have to remember this curve. To trip within 1 hour, the load must exceed 45%. Okay, that is under the IEC 60898 guideline on when shall a breaker trip. Okay, I think very simple for this one. Question number 5. Okay, this is not a quiz, this is just a question. Is it a quiz? Yeah, is it a quiz? Sorry, it's a quiz, but I forgot to put the the clock, the timing. MCB downstream is 20 M type C. To have 100% discrimination between downstream and upstream, if upstream is also type C, what is the nominal current of the breaker? Okay, regardless of the cable size, regardless of the cable size, just you want to show you in terms of discrimination. Don't worry about the cable size, but we calculate now
supply masuk.
to have certain 100% discrimination.
45M.
What will be the best or the minimum nominal current rating
Sekarang
of the
nak
upstream
100%.
breaker?
Nak 100%.
Okay, we'll give you 30 seconds from now.
Tapi sekarang dia tak mau, dia nak yang kecil tu. 30 dalam 30 minit. 30 saat.
Okay, the rule is for you to remember, I told you earlier, the upper limit of the downstream breaker must not touch the lower limit
Dia
of
tak
the
boleh overlapping
upstream
tau, jangan
breaker.
sentuh.
So now you need to calculate the upper limit of the downstream and the lower limit of the upstream. Okay, there's a question on MCCB. No, MCCB is a little bit different. MCCB shall not trip at 10% more, and it shall trip after that. Okay, what is the, for 1 hour tripping, I think it's the same at 45%.
Aduh, nak kena tengok balik ni kira ni. Lupa. Tak T ni. Kena tengok graf apa ni.
Anyone has got the answer for this? What will be the IN value of the upstreams?
40.
Mr. Jun, do not answer in the chat box. Please answer in using WhatsApp sent to you. If you want to answer in the chat box, you are not entitled for the hadiah.
Adakah MCB trip pada 30% dan 45% seperti MCB?
Okay, Fatin just told me the winners will be 3%, not 2%. Hari ni Fatin dia generous sikit, dia baik hati. Hari ni dia kata nak pilih 3 orang
MCB trip 30%
instead of 2.
MCB 45%.
So apa hadiah Fatin?
Awal orang buku kosong. Habis orang ni.
So Fatin said you will, as a token of appreciation, the 3 winners will receive power bank, okay, for your mobile phone,
Kalau power bank ada.
towels, small towels, hand towels, and booklet. Okay, Okay, first, this is the how you come up with the
Macam okey
answer.
lah. Apa limit?
The MCB 20M downstream, the upper limit is 20 times 10, which is 200.
Dia nak 100%
Okay, so
ni.
means that the lower limit of the upstream
Dia tak boleh
breaker must not be lower than
Ada beza tau.
200. Okay. So if
Dua
the
tu kan
lower
jawapan tu.
limit of upstream breaker shall not lower than 200 means
100% lah.
IN times 5
Dia dah ada
of
dispor
the
dia dah, dua tu.
upstream
Tapi
must
sekarang nak
be
100%.
bigger than 200. Okay, so what is the answer?
Tu.
40.
Ni dia ambil type B.
Okay, just now
Type C.
somebody posted
5 kali.
on the chat box 40M.
Tapi
so
dua
you got
tu
it
juga
right.
lah.
Okay.
Dia
Oh.
set
So
200 tapi
IN
ambil
must be
formula dia yang tu 5
bigger
kali
than
tu.
40M.
5 kali tapi 40.
Bahagi 5.
10%, 100% lah.
Tapi yang ni ratio dia. Ratio dia yang ni.
Okay, the
Tapi
answer
yang ni
for
asal
40M,
200.
answer bigger
Ratio
than
dia bagi
40M,
5.
which is
Disebabkan
the
type
next
ni.
one is 50. Or you may use 63, depends on your cable
40M.
size and other
Macam orang
loads
ni ingat.
downstream.
Kena tengok IN mana kita nak ambil tu.
Yeah, the answer is 50.
IN.
At least 50.
Nominal current kan.
Okay, now we go a bit more into the brother of the MCB, which is MCCB.
Brother dah.
MCCB comes in two different types, the fixed type and the adjustable type. Okay, some people call it type 1, type 2. Okay, so this is the fixed type where the overload and the short circuit or the inrush, the magnetic curve is fixed. You cannot adjust. Okay, and then this is the adjustable type. Okay, where you can adjust the long delay, the short delay, and the instantaneous. Okay, let me share with you what is long delay. The long delay is actually for the thermal protection against overload. This is this curve. Okay, the top part, this curve. And then the short delay is to protect against starting current, this one, okay, this part here. Okay, this is called short delay tripping adjustment. And then the third one is the instantaneous tripping. Okay, this part, this is for short circuit protections. And this is where you need to know your ICW rating of your breaker. If you have delay in the eye, if the eye is adjustable, then your breaker must be also comes with ICW rating, the short time delay braking capacity. Right? As what you call technology is always improving, moving forward. Even your mobile phone that you bought last year and today is already almost obsolete. You need to change to new one. Same with MCCB. In the olden days, everything is screwdriver type of adjustment, where you insert your screwdriver to adjust the dial in front of the MCCB. But today, in the comfort of your office, your chair, in the comfort of your bed, you can remotely control your MCB located somewhere in the world. I'm not sure in the moon, as long as in the world, I think today you can control, you can adjust your MCB setting on the long delay, short time delay, or in the instantaneous delay. And on top of that, your G also can be adjusted. G here is a ground fault adjustment. Okay, you can do it on the breaker itself by using the knobs given. Okay, or you can use your smart your smart mobile device to adjust the setting, or you can use the building management system software itself. Okay, let's say your building has a BMS. You can link your breakers to BMS by using all the different protocols. It has you need to have a compatible interface so that your breaker can talk to your building management system.
Yang kat kami ni, saya dapat BC, saya buka tu. Yang nombor 12 ada.
Okay, for ACB.
Nombor 12 betul.
ACB, there are two types of.
851.
Okay, I'm not saying that the ACB has two types, but when you talk about how to say, there is one device called ACB. There's another device called isolator. When you talk about ACB, the device must comply with IEC 947-2, where it has been tested for short circuit capacity to withstand a certain amount of short circuit current. If your breaker is only complying to 947-3 or -4, which is isolator, it has no test on short circuit. So be careful when you're buying this breaker. Make sure it complies with 947-2 as an ACB itself. Otherwise, it becomes isolator. No test on short circuit. So, but ACB by itself, it will not do any tripping. You need to add the tripping device, either the built-in, from the same manufacturer, okay, the tripping device, or you can use third-party tripping device, okay, the IDMT device or any what you call current sensors that is able to measure the short circuit, the overload, and to tell the ACB to trip via shunt trip or under voltage coil. So without all these accessories, your ACB is just an isolator because it has no tripping mechanism. Of course, people today in Malaysia, especially what you call, they choose third-party tripping mechanism or tripping device or sensor device compared to the same manufacturer tripping device because of the price. People are using maybe micro, what else? There are a few other brands that can be associated with the ACB to do the tripping for overload and short circuit. Okay, back to MCB basic. MCB comes with three mechanism. Okay, because I have to repeat this because people always ask me what happens if somebody block the toggle handle or the enclosure cover is too close to the toggle handle in such a way it blocks the handle from tripping. Please bear in mind that the internal mechanism is free from the toggle itself. It is not hard linked, means that the internal tripping mechanism can still trip even though the lever, the toggle switch or the toggle handle is in the on position or locked in the on position. Okay, that is called trip-free mechanism. Okay, some breakers come with PCI, normally the expensive one, the positive contact indicator, where there's a little window where you can see a flag. The flag can be green color or red color. If it's green color means the internal contact is already open. If it's the red means the contact is in the on or close position. Okay, that is PCI. Accessories, MCBs, Today, the accessories are getting more and more popular compared to a few years back. Okay? Few years back, it's very hard to sell auxiliary contact, shuntry, alarm contact. But today, a lot of people already started using accessories because of the BMS, the building management system, where they need to know whether the breaker is in on position, or trip position, or off position. And it can be remotely controlled, or just to add additional protection in case of maybe power failure. Breaker need to trip or to be attached with emergency button. For example, if you are designing petrol stations where you have the emergency mushroom push button located at all the what you call the machines, okay, the petrol machines where you fill your car with petrol. Okay, there's always, you can see near this machine there is a mushroom type push button marked emergency. Should there be any what you call problem, danger, you can just press this button. And this button actually is connected to the circuit breaker. Once you press, it trips your circuit breaker. In the olden days, you only able to do this with MCCB. But now, with the shunt trip and under voltage coil available for MCB, you may also use this for MCB. Okay, so you can use these accessories. Right now, remote on off. Okay, you can use also remote on off to control your breaker remotely, to reset your breaker, to switch off or switch on remotely. And you can set to autonomous function, where your remote on off can also do the resetting by itself without interference from remote function. But okay, the rule is this is not for residential. Okay, do not pasang this auto reset at home, because it is not allowed under the wiring regulation, Malaysian wiring regulation. It cannot be used for residential. Only for industrial and area where it is not manned by people. For example, the transmission towers up in the hill, maybe traffic lights, what else? TV transmission tower, mobile transmission tower, SCADA system for banjir and all those. Okay, you may use this. Last but not least, I would like to talk about the cable guide. Okay, many issues with loose contact. I think you also have experience on loose contact. Loose contact is not able to be detected by circuit breakers, by MCB, by fuse, or by RCD. Okay, loose contact arcing can only be detected by a device called AFDD, or arc fault detection device. So that is why it is very important to ensure that the cable is properly secured, okay, inserted with the right terminal and tightened correctly. So to achieve this, okay, some breakers may not be friendly enough. Okay, if you look at this breaker, I can say this breaker is not friendly enough because it leaves possibility for the installer to insert the cable at the wrong slot. Okay, imagine if you insert the cable here, then what will happen? When you tighten up the cage terminal, your cable is left behind. So example here, okay, you insert the cable here but you tighten here. Okay, that will cause loose contact. When you turn on the light, you may get the light, but then there is no proper contact between the cable and the terminal. One day it just bursts into flame. Okay, to avoid from that to happen, okay, some manufacturers already what we call include cable guide, so that there is no possibility to insert cable at the wrong slot. when talk about cable, then it is possible to do the pull test. Every time after you tighten up the screw, you can do a pull test. But what happens if you have COM bus bar? Okay, the bus bar that normally you insert on the MCBs. COM bus bar can be having so many teeth. Okay, could be 20 way, could be 15 way, whatever. So if let's say one of the teeth is wrongly inserted, you won't be able to know because you cannot do pull test. It's already tightened, but it happened to be behind the terminal, so that will cause a lot of issue later on. Okay, so I think done with this. Right, this is what I'm talking about, the COM bus bar. Talking about COM bus bar, it's good practice if we can differentiate between cable and bus bar. Okay, why? Because a lot of installation, they mix same terminal, they use bus bar there and they also insert cable there, which is not really good because there will be tendency for loose contact. Okay, that is why some MCBs come with two terminals. If you look at this MCB, there are two terminals here, the top terminal and the bottom terminal. The bottom terminal is dedicated for cable and prong type bus bar, whereas the top terminal is dedicated to fork type bus bar. Okay, what are the prong type and the fork type? Okay, this is the prong type. Okay, this is also prong type. This is the fork type. Fork type bus bar can be used here. Right. So if you have combination between bus bar and cable, it would be good to use fork bus bar on the top and you can insert cable at the bottom. So you do not share the same terminal to put bus bar and cable. Okay. And again, if you already use all the terminals, let's say you use fork bus bar and you will still want to use cable here, yes you can. You may use this connector. It comes with a fork type screw, fork type slot, and you can also add the bottom here to connect your cable. Okay, so try to use as much as possible combinations of bus bar and connectors. If you compare, I think some of you may have been overseas, especially in Europe, or you can see some pictures from internet, for example. You can see how good their wiring is. You know, they are very neat, very good and structured. Compared to our wiring style, sometimes okay, sad to say, but this is happening. It's very, what you call, Malay, because serabut. Serabut means wires goes everywhere. Okay. Try to be more professional. If you are a consultant, try to supervise the site installation of this cabling to ensure we have a better, what we call DBs for our users. Okay. Structured, neat, and using all the latest technology. Okay, in selecting COM bus bar, you make sure you choose between fork and prong, so that you can choose the two different terminals, the length, how many modules you need, poles. Okay, bus bar can be single pole, like this one is single pole, this one is two pole, okay, and this one is also single pole, but it's fork type. Bus bar also comes with specific rated current. For example, this one is, the top one is 63, this is also 63. This one I think is 80 amps. Okay, you look at the marking, it's shown on the bus bar itself, what is the rated current value. And it has to be insulated. Okay, under the wiring regulation, you're not supposed to use naked bus bar. Okay, that is why also why MCB today is rated IP20 fingerproof, and all other devices in the DB should also be fingerproof. So make sure your bus bar is also insulated. Okay, either it's ceramic insulated like this one or plastic insulated like this one.
Oh.
For MCB design, circuit board
design
design for residential, please include the 4 parameters that we have discussed just now in your design. What are the 4 parameters? The amps, the pole, the breaking capacity, and the time. Okay, do not omit any of these in your design, because once you omit any of these, it's subject to ambiguity and subject to what you call, contractor may give you different breakers. Example, if you ask for 2 pole but you do not specify, then contractor may give you 1 pole. Okay, in KA also the same. If you do not put the KA, let's say you ask for 10 KA, but then in the drawing there is no KA, contractor may give you lower KA. Okay, so these 4 parameters are actually, I can say, a must for you to put in the drawing to avoid any discrepancy. Try to follow this suggested design, proposed design by Suruhanjaya Tenaga to segregate between socket and the rest. Okay, socket is must be protected by 30 milliamp RCCB, whereas lighting, aircon, fan, you can use 100 milliamp RCCB. Okay, so you split into 2. So let's say there is fault here on the socket outlet circuit, you will still have lights turned on. Okay, it is not affecting your lighting circuit. So that is the purpose. And if you have water heater, okay, you may use another branching from here to your water heater, or you can also tap it from the lighting circuit or the socket circuit. Many would put on the socket circuit because of 30 milliamp RCCB is more sensitive. But there is no fixed rule on this. Okay, it's up to you to design. For me, personally, I would just branching from the main here, okay, to your water heater. No need to have additional backup RCD. But if you prefer to have backup, then you tap it from here. Okay. Now we go to the conclusion of circuit breaker selection. Okay, remember the 2 different standard, IEC 60898 for residential, 947-2 for industrial standard. Breaking capacity, MCB only up to 25 kA. If you need more, then you use MCCB or ACB. Once you use MCCB, ACB, you need also to know the ICU, ICS, ICW rating. Whereas for MCB, it's enough for you to understand ICN, the nominal breaking capacity. Rated current, it depends on your cable size. Then you choose your rated current. Poles, remember, try to avoid using SPN and TPN MCB unless you are sure what you need. Okay, I have not included the SPN and TPN here in the selections purposely because I want to make sure that people will not get confused. Okay, stick to 1 pole, 2 pole, 3 pole, and 4 pole breakers unless you really know how to use SPN and TPN breakers for certain applications. In terms of installation, there is no removable or draw out MCB. Okay, but MCCB, yes, you have a fixed type or draw out type similar with ACB. In terms of curve, the tripping curve, MCB is all fixed. You cannot adjust anything, and you may choose between B, C, and D. Whereas MCCB, you have the two options, the fixed type or the LSIG type. Okay, for the fixed type, there are also two types of, for the adjustable type, there is also one type of MCCB which is fixed, which is adjustable on adjustable on thermal overload but fixed on magnetic. Okay, there's another possibility also. Okay, so we have fixed, adjustable, and adjustable. Adjustable here means both the thermal is adjustable and the magnetic is adjustable. Okay, for further on the MCCB ACB selection, besides the nominal current, you need to know also the ICU, ICS, ICW selection, fixed or adjustable, LSIG setting, number of poles. Okay, for MCCB, ACB, normally people will use 4 poles only for the main incoming, or should you are using ELR for what you call for ground fault current. When you use ELR, you must use 4 pole. Why? Because ground fault can also be between neutral and earth. So if only using a 3-pole breaker for the ELR, then should the fault is actually between neutral and earth, you are not able to isolate the neutral pole. So that's why it's always advisable, if you are using ELR, to use a 4-pole breaker to ensure when there is fault between neutral and earth, you can also isolate that fault. Okay, so today we have discussed on the MCB protections, which cover overload and short circuit, but we are not yet covering on the ground fault or leakage fault and the arc fault. Arc fault, remember I told you, can only be detected by using AFDD, okay, like this, AFDD. For Malaysia, AFDD is not mandatory yet, okay, unlike America, Canada, and some European countries. AFDD is mandatory. Malaysia, no, okay, it's not mandatory protection system. Okay, but to tell you the truth, that is why we need AFDD is because of the frequency of the electrical fire.
Okay.
When there is fire, okay, this is true for Malaysia. When building when a building burn, okay, when there is a fire in a building, the report, well, I can say 90% or maybe more than that, will always say that it's due to short circuit.
Okay.
Okay, unless you can see people put fire on the building.
Okay.
Okay, otherwise it will be due to short circuit. But believe me, short circuit is not the culprit. But most of the issues of building fire, if it's due to electrical, is not by short circuit, but it is due to arcing. And arcing can mainly due to loose contact or heating wiring. Okay, where arcing is neither overload nor short circuit, but cause a spark. Okay, between the contacts, between if there is a crack or if the cable is broken, so there will be arcing between the 2 points, and it will start to break fire, and one day can burn the whole building. And this can only be detected by AFDD, not by the breaker, not by the RCD. Alright, it's already 12 o'clock. I think I should stop here. As I mentioned to you, conducting online webinar is not as easy as live seminar because
Okay,
it's
okay.
very tiring.
Kalau Cikgu P sana,
So
buat
that
ni,
for this we will take a 2 hours
minit
break
ke,
for
lambat
lunch.
ke apa sikit lah.
We will continue our session after 2 p.m. Okay, so you can have a good lunch. And we will see you again at 2 p.m. to discuss on RCD. Alright,
Okay,
with that, thank you very much for staying with us throughout the morning. And enjoy your lunch. We'll see you again at 2 p.m. Thank you.